where all reactions have reasoning and energy is always present.
Hey, graduate. I periodically think about chemistry.
Well, the first thing to learn about chemistry is the periodic table.
The periodic table has many groups comprised of elements with some of the same traits. Group 1, for example, is called the alkali metals. This group is highly reactive with water and other compounds.
Group 2 has the name of alkali earth metals. This group is made up of elements mainly found in the Earth's crust. The transition metals are groups 3 through 12 and are very ductile, malleable, and are good conductors.
The boron, carbon, and nitrogen families, groups 13 through 15, are gases and metalloids. The oxygen family, group 16, also known as the chalcogens, is a main group on the table and is mainly made up of stinky gases.
Ew. Group 17, the halogens, is a very desperate group due to its number of electrons in each atom, but that's later on. Anyways, the gases in this group are highly poisonous. And finally, there are the noble gases.
Like me?
Yes, like you, Napoleon. These gases are unreactive at room temperature and include the infamous element neon.
Now, our viewers may be wondering, how on earth do you find the information you need for a certain element?
Well, it's as easy as Stoic.
You're funny. Stoic's not easy. But back to our conversation. What if I needed to find the basic information on an element? What do I do?
Well, first, you'd have to find the element. It's always good to know the element's symbol and or atomic number. Once you locate the element you need, all the information is in the box. There are different ways to set up an element's information. It is different for each type of periodic table. On most periodic tables, the mass is located at the bottom with the atomic number at the top and the symbol in the middle.
Oh, now I understand. So once I know the mass and the atomic number, I can use the man section of 8-man to calculate the number of neutrons in that specific element. And I can find other basic information of the element as well.
Exactly. And you know how we mentioned group 17 as being desperate?
Yes.
Well, each group determines the amount of valence electrons in each element in that group. Group 1, for example, has 1 valence electron. And as you go down the periodic table, the valence electrons increase with the group. For example, the elements in group 17, the halogens, have 7 valence electrons. Elements need 8 valence electrons for its last electron shell.
Oh, so that's why group 17 is so desperate. They crave that last valence electron so they will cling to anything.
That's right. Now, with elements comes different ions. Ions are atoms or molecules which have gained or lost 1 or more valence electrons. The 2 types of ions are cations and anions.
Now, cations are atoms that gain valence electrons to give them a net positive charge, and anions are atoms that lose valence electrons to give them a negative charge. The saying you need to always remember is,
I like cats. Cats are positive. I hate ants. Ants are negative.
Another major part of chemistry is chemical reactions. Now, there are 5 types of chemical reactions: single displacement, double displacement, combustion reaction, decomposition reaction, and synthesis reactions.
single displacement involves 3 chemicals. A plus BC equals B plus AC. Chemicals A and B switch places during the reaction, causing A to bond with C and B to go off on its own. Now, double displacement involves 4 chemicals. AB plus CD equals CB plus AD. In this reaction, chemicals A and C switch places and bond with the opposite partners.
Combustion reactions involve the reactants of a hydrocarbon and an oxygen molecule, and always contain the end products of carbon dioxide and water. Decomposition reaction involves the breaking down of the reactants into the basic products. AB equals A plus B. The chemical bond between chemicals A and B are broken, and result in the separation of the two chemicals.
Now, synthesis reactions are the opposite of decomposition reactions. Synthesis reactions involve the bonding of two chemicals. A plus B equals AB. Chemicals A and B bond together to make the compound AB. And after months of studying and working hard, you get introduced to us. You have to jump faster. Anyway, now a mole is a unit of measurement used in chemistry. It is typically used to determine molar mass or the amount of molecules in an element or compound. For example, 1 mole of an element is equivalent to its mass. Oxygen's molar mass is 15.999, and carbon's molar mass is 12.011. If the amount of an element changes, the molar mass changes. If there are 2 atoms of oxygen, then the molar mass of that molecule will be twice as much as oxygen alone.
A mole is also equivalent to 6.0221 times 10 to the 23rd. This is the amount of molecules present in one atom. It can be an oxygen atom, hydrogen atom, lead atom, anything. If there's one atom, there will always be 1 mole of molecules present. This concept holds the same rule as the molar mass of an element. If there are 2 atoms of an element, the amount of molecules will be twice as much as the element alone. The amount of molecules in a mole was discovered by Amadeo Avogadro. To convert a chemical reaction and its reactants and products to molar mass or molecules, you just need a simple equation. But that's something your teacher can teach you. Well, that's our lesson for today.
Come back soon, and remember,
Chemistry is all around, so keep a lookout. High five. Was discovered by Amadeo Avogadro to convert a chemical reaction and its reactants and products to a molar mass or molecules. What? Don't record me. I'm so busy, you don't even understand. I'm tired of this project. I'm tired of this school. I want to leave. Mole is also equivalent to 6.0221 times 10 to the 23rd. This is the amount of atoms present in... I hate it. Do this mold.
You should.
I'll just start at mine.
Okay.